Hi guys, welcome to my YouTube channel. I'm here with another tutorial in which I'm going to discuss about the rigid body. What is rigid body and what is its usage in our Unity projects? So basically, when you attach the component of rigid body to any object, it allows that object to be influenced by the physics game engine. This means that it will act like a real-time object. All the forces, be it collision, be it friction, or the gravity, they will start acting on that object. Let's see it practically. Let us create a 3D object cube and hit on play button. Now you will see that there will be no change in the position, rotation, or the scale of the object, and it is static exactly where we placed it. But when we attach the rigid body component, immediately the physics started acting on this object and it fell down, and that was due to the gravity. So let's see in detail that what is a rigid body component. In rigid body component, we have several factors. Number one is mass, which is very important because mass actually determines that how our object is going to act when several forces act on our object. Then there is the factor drag. Drag is also very important because it controls the pace of the object when the force is applied, and that is actually the damping factor in the linear motion, as we can see when we point on this parameter. And then we have this angular drag. Angular drag is same as as this drag, except for the fact that uh, it acts when the torque is applied. So angular drag is basically the factor that in real world, when you see that we have an object and there is the resisting factor of air in it. So to give that realistic impact, we have to see uh, we actually angular drag determines that if the object is rotating or spinning, so how much time it will take to stop the rotation. So it is the angular drag due to which our object eventually stops the rotation. Then we have automatic center of mass. Okay, by default it is checked. Automatic center of mass is the factor which uh, automatically calculates that where is the center of mass. And this is very important in physics because now in this cube, this is right now the center of mass, which is exactly in the middle of the cube, as you can see from every angle. So the rigid body considers this the center of mass. So you have the option to specify that what can be the center of mass, but by default this option is checked and automatically the physics engine determines that where is the object center of mass. Then we have this automatic tensor. Automatic tensor is a moment of inertia. It determines that when the object is going to start rotating, uh, after the application of force, that how hard it is for the object to start the rotation. So it is the moment of inertia, and by default this option is checked. It calculates on its own how the object is going to rotate. Then we have this gravity. Gravity is the component due to which the object moves downwards, like we have the real world gravity. Then we have this is kinematic. Is kinematic is by default unchecked, and when we check it, no force acts on the object. Is kinematic is the parameter that determines whether our object is allowed to experience all the environmental forces to act on it, or we don't need that. So sometimes there's a scenario in game where we have to keep this option unchecked, but there can be scenarios where we, for a while, check it. So this is also one of the factor. Then we have interpolate. Now interpolate is two types. Now by default it's none, and then it's interpolate or extrapolate. This is a detailed factor on which I hope that I'm going to make a tutorial soon. But for now, you can uh, just leave this factor. Then we have this collision detection. Now, collision detection is having so many types like discrete, continuous, and continuous speculative, and then we have continuous dynamic. For by default, it's discrete, that it is not calculating the collisions that frequently in the game. But when we have, let's say, an object moving at a very fast pace, be it the car, be it ball, any object that is moving at a faster pace, sometimes the collisions are not detected, and that is the time when we select continuous dynamic or continuous speculative. So by continuous, what happens that it doesn't leave any room for the collision to be missed. So this is collision detection. Then we have constraints. Let's say we want the force to be applied only in y direction, but due to this rigid body component attached, it's acting very naturally and the force is acting in all dimensions. Then we have this option where under the constraints section you can see this freeze position and rotation. So for that, we are going to freeze the x-axis and also the z-axis. Hence, the object will only be able to move upward and downward. And same goes with the rotation also. If you have to rotate it in any one axis or two axis, you can keep them unchecked, and the remaining you can keep checked. So by default, all these are unchecked. Then we have an interesting factor, that is the layer overrides. Now it's having two options, include layers and exclude layers. In my opinion, one was enough, but it's okay that we have two here. It actually tells that which are the layers uh, with which the collisions should happen. So for that, you can select any layer. Right now, here is selected nothing and exclude layers nothing. So this option is by default. We give, there is no parameter mentioned over here. But uh, there are layers with which at times in our game we want our object to interact with. For example, there is we want this object to collide with only the enemy objects and not with the player objects. So we are going to exclude layer of, let's say, the player layer. So it won't be colliding with the player object. So this is it about the rigid body component. If you have any question, don't hesitate to ask in the comment section. Like, share, and subscribe. Other than that, I'm going to make another tutorial that will be the tips and tricks regarding rigid body, which usually the experienced developers know. So right now, that's it for this video.